If you want to detect objects in images as shown here, then this video is for you. Here we shall learn about the Faster-RCNN algorithm, which is one of the most popular and widely used object detection algorithm. By the end of this video, you shall get the complete picture of the Faster-RCNN pipeline. So let's begin. This is a two-step process where in step 1, we obtain several regions of interest in the image in which there is a possibility of an object. We call these regions as region proposals. We also obtain an objectness score for each of these region proposals. These region proposals are then passed to a detector, which is step 2. Detector then predicts the class of the object contained inside the region proposals and also fine-tunes the region proposals. After some post-processing, we obtain the final output as shown on the right. This idea was first proposed in the paper RCNN as shown here. But both the steps were very slow and the entire system was not end-to-end trainable. Hence they came up with the paper Fast-RCNN where they mainly tried to improve the speed and accuracy of the detector part, which is step 2. But still the region proposal step, which is step 1, was not very efficient and also the entire system was still not end-to-end trainable. Hence they finally came up with the paper Faster-RCNN where they mainly focused on improving the speed and efficiency of the step 1. They introduced a region proposal network in this paper which obtains high quality region proposals which are then used by the Fast-RCNN detector. This improved the overall accuracy of the object detection and also it made the entire system end-to-end trainable. This then became the most popular and widely used algorithm for object detection. Hence, it is very important for us to study this in detail. Having understood the overview, let's go a little deeper and try to understand each of these steps in some detail. First, let's try to understand the region proposal network. A region proposal network outputs several region proposals, each with an objectness score. Let us see now how this is done. To do that, we define a set of reference boxes called anchor boxes all over the image as shown here. For simplicity, I have shown only 3 anchor boxes at each location, but in the paper they use 9 anchor boxes having different scales and aspect ratios. Now the task of the region proposal network is to predict rough offsets with respect to each anchor box and also predict the objectness score. For example, let us consider one anchor box present here. I have enlarged the region for better understanding. Let us say that a white box shown here is a good candidate for a region proposal that we wish to obtain. We first parameterize these boxes by defining the center coordinates and the width and height. Now the task of the region proposal network is to predict offsets for center coordinates and width and height of the anchor box as shown here. Once we predict these values, we can then obtain the X5WH of the required region proposal. This is done for all the anchor boxes, and as you might have guessed, through this process we get several region proposals. We then shortlist few candidates using the objectness score and a technique called non-maximum suppression, which we shall discuss in detail in the later videos. The shortlisted candidates are then given to the detector for further processing. Now let's try to understand the Fast-RCNN detector. Here an input image is first passed through a set of convolution layers which obtains feature maps. These feature maps are then used by the region proposal network to obtain numerous region proposals. Now inside the detector, we pass these feature maps and the region proposals and proceed as follows. First, each region proposal is mapped onto the feature maps to extract features. The extracted features are then passed through a ROI pooling step which gives us fixed size features. ROI pooling step is used because each region proposal is of variable size and this gives us variable size features. To obtain fixed size features, we use ROI pooling step. These pooled features are then given to two parallel branches as shown here. In the first branch, the classifier tries to predict the class contained inside the region proposal, and in the second branch, the regressor tries to fine-tune the bounding box coordinates of the region proposal. This process is repeated for all the region proposals which are produced by the region proposal network, and after some post-processing, we obtain the final output as shown on the left. So this was the overall picture of the Faster-RCNN algorithm. If you want to learn more about region proposal network and Fast-RCNN detector in more detail, I have created in-depth videos on my channel. I have provided the links in the description. So this comes to the end of this video. If there are any suggestions or comments, please let me know in the comment section below. I hope this video was informative. Thank you very much for watching.